Okay, welcome to our final example on volume flow rate. So in this example, we have this bathtub, and please excuse me for this poorly drawn bathtub, but this bathtub can hold up to 300 liters of water. And the water is flowing through this 2 centimeter diameter pipe, and it states that the pipe can fill up the bathtub the full 300 liters in 5 minutes. And the question is asking, what is the speed of the water in the pipe? So I'm going to treat the water in this system as an ideal fluid. And if you don't know what an ideal fluid is, I would highly recommend watching some of the earlier videos in this playlist where I talk about the ideal fluid model and how we can use this model to come up with the equation of continuity and flow rate. But in summary, an ideal fluid is essentially a simplified model that makes 3 assumptions. One is that the fluid is incompressible. Secondly, that the fluid is non-viscous. And finally, that the flow is steady, or a laminar flow. So that's what an ideal fluid is. Okay, so when we have an ideal fluid, we also have this thing called a flow rate, and that is usually denoted by the letter Q, and that is equal to the velocity times a cross-sectional area. So how much volume of liquid is passing through a certain point per second, or per unit of time. And the units of this is meters cubed per second, right? How much volume is passing through a point over a given amount of time. That's the flow rate. So for this question, we can figure out what Q is right off of what has been given to us. So we know that the bathtub capacity is 300 liters. That's the volume. And we know that that bathtub can be filled up through this pipe over the course of 5 minutes, volume per unit of time. So the flow rate in this example is going to be 300 liters, that's the volume, divided by the time span, which is 5 minutes. Again, if we treat this water as an ideal fluid, then we know that the volume passing through the pipe is 300 liters per 5 minutes. So this turns out to be 60 liters per minute. Now we do need to convert this into meters cubed per second because that's the consistent units of what I have written over here. So down here, I'm going to say that 60 liters per minute. Well, let's do the conversion here. So let me first do the liters, and I've written the conversion factors that we may need up here. So in order to get liters into meters cubed, I need to use this conversion factor. In 1,000 liters, there is 1 meter cubed. Okay, cool. That's going to cancel out the 2 liters, and we're going to be left with meters cubed. Now, what about the minutes? We need this in seconds. So I can use this conversion right here. 1 minute equals 60 seconds. So in 1 minute, there are 60 seconds. But the minute units cancel out, and we're going to be left with seconds. So we're going to be left with meters cubed over second once this conversion is done. So if we take 60 divided by 1,000 divided by 60, then we're going to get a flow rate of 0.001 meters cubed per second. Okay, cool. So we figured out what the flow rate was, but the question is asking what is the speed of the water in the pipe. So if you remember, Q is equal to VA right here, the velocity times the cross-sectional area. Now the area is going to be the area of the cross-section of this pipe. Now we know that this pipe has a 2 centimeter diameter, and this is a circular pipe. So the area of the pipe is going to be pi times r squared. Okay, well, what is r? Well, if the diameter is 2 centimeters, then that must mean the radius is 1 centimeter, right? Diameter divided by 2. But again, you'll notice that this is in units of centimeter, and we want this in meters because we want to stay consistent over here. So in order to convert centimeters into meters, I can use this 100 centimeters to meter conversion. And the radius is, well, 1 divided by 100. That's 0.01 meters. If I said that Q is equal to VA, we can use this equation to figure out what V is, the speed of the fluid through the pipe. So Q we've already figured out. It is this 0.001 meters cubed per second. So 0.001 meters cubed per second, and that's equal to the velocity, which is unknown, times area. And area was pi times r squared, and r was 0.01 meters squared. Now, if we plug this into our calculator, we get that the velocity going through the pipe is about 3.1831 meters per second.